What if I give you this function? This is just review of yesterday, then we're moving on. Vertical asymptote equals, horizontal asymptote equals, domain, range, X intercept, Y intercept. What's my vertical asymptote based on? Always. The MPVs, the denominator, right? Vertical means that's cut to the x-axis. Vertical lines only occur when it's x equals lines. Horizontal lines only occur when it's y equals lines, right? So vertical asymptote, when I solve this out, I'm going to get 2x minus 7 equals 0, 2x equals 7, x equals 7 over 2. So at 3.5, that's where my vertical asymptote is. My horizontal asymptote, we use the rules, right? If the numerator is smaller than the denominator, what's my vertical or my horizontal asymptote at? Y equals 0 every single time when the numerator is smaller than the denominator. The domain is just based off of your vertical asymptote, x, such that x can't equal 7 over 2. I'll do interval notation on the next one. The range is y can't equal 0. When you hear X intercept, you should think what? Every single time, doesn't matter what unit we're in, y equals 0. So we're going to get 0 equals 3 over 2x minus 7. The first thing you're always going to do is you're going to take this whole bottom, whole denominator, bring it up. 2x minus 7. What's 2x minus 7 times 0? 0. So 0 equals 3. Is that true? No. What does it mean? There are actually no x-intercepts. So whenever you don't have a variable in the numerator, you're not going to end up with any x-intercepts. Why is that? Because you have an asymptote on the x-axis. How can you have an x-intercept when you have an asymptote on the x-axis? You have a thing that says it doesn't exist. Nothing can exist on the line y equals 0. That's what you're saying because there's an asymptote there. Y equals 0 is the x-axis. So nothing can exist on the x-axis. Therefore, there are no x-intercepts. So your x-intercept is completely based on the numerator of your rational. If your numerator doesn't have an x, you're not going to have any x-intercept. Y-intercept is when x equals 0. So y equals 3 over 2 times 0 minus 7. So it's 3 over negative 7. So my y-intercept is at 0 and negative 3 over 7. Okay? Now a diploma style question exactly like that. Example, f of x equals a over bx minus d. Vertical asymptote. I'm going to do my numbers. 2, horizontal asymptote. 3, domain. 4, range. 5, x-intercept. 6, y-intercept. Try that one. Often it'll say to you like A, B, and D have to be greater than 0. You could go like 2, 3, and 4 and try it out that way as well, right? And place them back in. So vertical asymptote is the non-permissible values. So bx minus d equals 0, bx equals d, so x equals d over b. So my vertical asymptote would be at d over b. The numerator is smaller than the denominator. So my horizontal asymptote is at y equals 0. Doesn't matter what any of those letters are. The domain, if I do interval notation, it's going to be from negative infinity to d over b, round bracket because it's not equal to that, because that's where the asymptote's at, or d over b to positive infinity. This little symbol is a union symbol. It means or. You can't say and because you can't be here and here. It's on two separate sides, right? So you have to say or. The range is just y equals 0. So you can go, or the range is it can't equal 0, sorry. So you can go negative infinity to 0, 0 to positive infinity like that, or negative infinity to 0, or 0 to positive. Either way is fine. The x-intercepts, there's not going to be any. You don't have an x in the top, and the entire denominator is going to cancel because you're going to have 0. So 0 equals a over bx minus d. This entire denominator, you bring up here and multiply it. It's going to go away. Now, this is where people go, they go 0 equals a. So they say a equals 0. A can't equal 0. The whole thing would go away. A is a number. It's like 3 or 7, right? That'd be like saying 0 equals 3 or 0 equals 7. There's no x-intercept. You can leave yourself a little note if you want and say, if there's no actual variable, because remember the variable in this question is not a, b, and d. The variable is x, right? Is there a variable up here? No, a represents a number, not a variable. So if there's no variable in the numerator, you will have no x-intercept. Leave yourself a little note if that's something you want. Little star, star, star. No variable in numerator equals no x-intercepts. Because you only have a variable in your denominator and you bring your whole denominator up and multiply by 0, it goes away. You have no variables left. Can't solve for a variable if it doesn't exist. And the y-intercept is going to be y equals a over b times 0 minus d. So y equals a over negative d, or negative a over d, or negative a over d. Either way, same thing. So if we want to write it as a coordinate, it'd be 0 and negative a over d. Okay? Now what if I give you this example? G of x equals 4 minus 1x over, it won't be written as 4 minus 1x. It's nice to me, but it won't be written that way. 4 minus x over 3x plus 7. Horizontal asymptote. Vertical asymptote. Domain. Range. X-intercept. Y-intercept. I switched these specifically just in case you just thought you could go in order. Horizontal asymptotes are when y equals 0. You need a horizontal line. So y equals 0 in this case. They're the same degree. So if they're the same degree, you take a coefficient of the numbers in front. I specifically switched these so that you might do 4/3. It's negative 1 over 3. The vertical asymptote is just what your non-permissible values are. So x equals 3x plus 7, x equals, come on, 0 equals 3x plus 7, 3x equals negative 7, so x equals negative, what is going on? X equals negative 7/3. The domain If set theory, it's really, set notation, it's easy. X can't equal negative 7/3 because that's where your asymptote is. And if it's range y such that y can't equal negative 1/3. The x-intercept of this one, it's going to be 0 equals 4 minus x over 3x plus 7. You take the entire denominator up here and multiply it, it goes away. So you're left with 0 equals 4 minus x. So x equals 4. So it's at 4 and 0. So basically, the way to think about this is if you go backwards to try and make this equation, the bottom of this equation is found from the vertical asymptote, right? The top of this equation is found from the x-intercept. If you don't have an x-intercept, then the top is going to be just a number. Okay? The y-intercept is going to be y equals 4 minus 1 times 0 over 3 times 0 plus 7. So y equals 4 over 7. And then the last type, y equals, x squared plus 12x plus 32 over x squared plus 10x plus 16. First thing you're going to have to do is factor x plus 8, x plus 4, 16 is x plus 2, I'll go 8 first, x plus 2. So if two factors cancel, what are we left with? A point of discontinuity. So these babies cancel. So my point of discontinuity still is going to be at x equals negative 8, because you solve it just like you did before. It's going to be at negative 8 and something. How do I find that something? That would make this a standard of excellence question. How do I find that y value? Plug it into this equation once you've canceled these off, or else it's going to get you 0 every time and get your y. So you're going to get y equals negative 8 plus 4, I'm not sure what I'm putting in brackets, over negative 8 plus 2, I did it again. So it's going to get you negative 4 over negative 6, which is 2/3. So the point of discontinuity is at negative 8 and 2/3. What happens with these two? What does this get you? This gets you your vertical asymptote. It's at x equals negative 2. Your horizontal asymptote is at y equals 1. The reason why that is what you have left over is the same degree, so you take the coefficients of the two. Now, a lot of people will tell me, okay, well, my x-intercepts are at negative 8 and negative 4. You told me whatever's up here gets me my x-intercepts. Remember, this is a point of discontinuity, so it goes away, right? That goes away. She gone. We use what's left over to find the x-intercepts. That was funny, but I only had one person smile. Now two, because I think someone's feeling bad for me. All right. X-intercepts are going to be 0 equals x plus 4 over x plus 2. I'm going to go extremely monotone. For the x plus 2 up here, cross them off, and you're left with x plus 4 minus the 4. X equals negative 4. Negative 4 and 0. That's great. Okay, y-intercept. Don't know why monotone means nasally, but it is. Y-intercept, sucks to be whoever has to listen to this. There's about 4 of them missing. Good luck. Y-intercept is 0 plus 4 over 0 plus 2, which is 2. So that would be 0 and 2. Good times. Okay. Transformation of rationals. That was a straight line. What in the good times? Okay. Transformations of rationals are in the form y equals a over x minus h plus k. So you have vertical stretch, possibly. Horizontal translation, vertical translation. So this form helps you actually be able to get like a basic rational graph with a vertical asymptote and a horizontal asymptote and get the equation of it. This form helps you with that. Okay? There's another way to do it if it has a point of discontinuity, which we will be going over those in a second. So say I give you an example. Y equals 3 over x minus 4 plus 7. Your basic rational graph is y equals 1 over x. So if it's not 1 over x, stuff has happened. Things have been done did. Yes, they have. All right. A always represents what in transformation? Vertical stretch. So we have a vertical stretch by a factor of about the x-axis. You have a horizontal translation for, what have you always done the whole time? It's going to be the same. For right. And you have a vertical translation 7 up. Now, what's great about this form, you don't get it often, but what's great about this form is your normal exponential, or whoa, I'm flying back a few units. Okay, your normal rational graph, this one has asymptotes at 0, 0, right? What's the only thing from exponential and logs that moves an asymptote that's horizontal? What's the only thing that moves a horizontal asymptote? Something that moves me up and down, right? So vertical translation, so that's why exponentials only move with the vertical translation. What moves a horizontal asymptote? Horizontal translation, that's why logs only move with the horizontal translation. So what's great about this? This is where the asymptotes normally are. This horizontal translation says the asymptote moves forward to the right. So my horizontal translation is actually my vertical asymptote. So my vertical asymptote is at x equals 4. My horizontal asymptote is normally at 0. It's been, the whole graph has been moved 7 up. So my horizontal asymptote is at y equals 7. In this form, you don't have to memorize the 3 rules. 97% of the time, they don't give it to you in this form. So you need to know your 3 rules. If you're someone who's like, I'm just going to do this. It's not going to happen. Okay? Honestly, that is transformations in a nutshell. Yeah. What happens if I get, okay, punch this into your calculator just for fun. Into your y1, put in 1 over x. In your y1, put in 1 over x. In your y2, put in 5 over x. So in your y1, you have 1 over x. In your y2, you have 5 over x. What happens? Just stretches, right? Just a vertical stretch. Did my asymptotes change? No, because I'd have x plus 0 here, technically, or x minus 0, and a plus 0 at the back. So that was a 0, 0. Here I'd have a 0 and a 0, technically, if I drew it in that form, right? So they didn't change. What happens, though, leave this one in, y equals 1 over x in your y1, but in your y2 now put in negative 1 over x. What happens? It's reflected in the what? Reflected in the x because it's with that a value, right? It's a vertical stretch. Vertical stretch about the x-axis. This would be a reflection in the x-axis. That's all the really difference that happens with that. Okay. The last thing is the one thing that people find the hardest, coming up with the equation. So I have these printed off for you. Okay, there's two different methods to do equations that are the easiest for each different one. So if there's not a point of discontinuity in the graph, we do one way. If there is a point of discontinuity, we do it another way to find the equation. Okay? Remember when we found polynomial equations way back when? We took the x intercepts, we put them down, and then we put an a value in front because we always had to check if there was a vertical stretch. Same thing here. We're always going to have to check if there's a vertical stretch or a reflection, that negative that made it go the other way, right? So remember, if the graph is in these two quadrants, then our a value is positive, right? Because it moved it to the other two quadrants when it was negative, right? So for these ones here, they're all positive. Ooh, what's this one? Just a point of discontinuity, right? So we're going to have to figure that one out. All right. So does this graph have a point of discontinuity on it? No. If it doesn't have a point of discontinuity, the easiest way to do this one is in that form, y equals a over x minus h plus k. In for h, we say how much it shifted. Remember, these asymptotes have always, when they started without any shift, are on zeros, correct? This asymptote is no longer on x equals 0, it's on x equals 1. It moved 1 to the right. So I'm going to get y equals a, I don't know, x minus 1, because it moved 1 to the right. My vertical asymptote is normally on 0, it moved 1 to the right. My horizontal asymptote is normally on 0, it's moved 3 up. So what do I have to do? Plus 3. How do I find this little a? How did I find the a when I did polynomials? Yeah. Put in a point. Should I use just one of these random points back here and just guess? Or should I use one of the bolded points that they bolded for us for a reason, for bolding it? The bolding one, please. Okay? You don't know how many people on a test picked like, I don't like your bolded one. I'm going to use something different, like 1.379 and 2.554 randomly. It happens. Don't be that person. Okay. So I'm going to use, it's really hard to see. Is it 0 and 1? I think it is. 0 and 1. Okay, let's fill in 0 and 1. So we get 1 equals a over 0 minus 1 plus 3. Some people try and move this first. Don't. Move the 3. If I subtract 3, I get negative 2 equals a over negative 1. What do I have to do with that? Bring it up. Negative 1 times 2 is 2, so a equals 2. So what's the equation of this graph? Y equals 2 over x minus 1 plus 3. If you remember these rules, for when it doesn't have a point of discontinuity, very easy to make the equation. Now, what's the problem if they don't give it to you in this form and they give it to you in the form where it's like they want it as like ax plus b over cx plus d, then we have to put it together. So you just make a common denominator here and put them together. So this is one answer that's correct, but they might make you do the common denominator one. So I'm going to do that on the next page. Maybe. Y equals 2 over x minus 1 plus 3. Was that what it was again? Yeah. So you can flip this over and do it on the back. You have an open spot if you want to try it. So I'm going to multiply this by x minus 1 over x minus 1. And so I'm going to get y equals 2 over x minus 1 plus 3x minus 3 over x minus 1. Once we have a common denominator, we can write the whole numerator over one denominator. So we get y equals 2 plus 3x minus 3 over x minus 1. So y equals 3x minus 1 over x minus 1. Okay? Look at the one to the right, the graph to the right of it. Does it have a point of discontinuity? Is there any open dots? No. That one and the graph below the one we just did, both don't have points of discontinuity, and neither does actually the top four don't, I'm sure. So do the top four. All right. So this one you're going to get y equals a over your x shifted 4 to the right, x minus 4. Your y shifted 1 up, so plus 1. The coordinate -2 and 0. So 0 equals a over -2 minus 4 plus 1. Do my 1 over first. Don't try and like multiply them and say it goes away or something. People do that. -1 equals a over -6. Multiply my 6 up, so 6 equals a. If I got a -6, would I should be like, hey, no, something is wrong. Because if it's in the top right and bottom left, my a has to be positive. Because if it's negative, then it's going to be here and here. Remember, it does that reflection. So if it's in the top right, it's right and it's positive. Okay? So my equation is y equals 6 over x minus 4 plus 1. Y equals 6 over x minus 4 plus 1. And I have to get a common denominator. So x minus 4, x minus 4. So I'm going to get y equals 6 plus x minus 4, because when I distribute a positive 1, and it's not going to do anything, over x minus 4. So y equals x plus 2 over x minus 4. And I'm done. Okay, the third one, I have y equals a over x. My x moved 2 to the left, so plus 2. 4 down, so minus 4. The point, is this -1, -1? I think so. -1 equals a over -1 plus 2 minus 4. -1 equals a over 1. I'm just going to write a. So a equals, add the 4, 3. So I'm going to get y equals 3 over x plus 2 minus 4. Which is a good answer, but if I want to put it together in the other form, it's going to be y equals 3 over x plus 2 minus 4, x plus 2, x plus 2. So you're going to get y equals 3 minus 4x minus 8 over x plus 2. So you're going to get y equals negative 4x minus 5 over x plus 2. Wow, my computer is writing really awful. Ah. Okay, this one's going to be y equals a over x shifted 2 to the right, so x minus 2. Y shifted 3 up, so plus 3. You can use the point. I'm going to use 1 and 2. So I'm going to get 2 equals a, 1 minus 2 plus 3. 2 equals, and I'm going to write it this way because I'm lazy. 1 times negative 2 is negative 1. I can write it as a over negative 1, or I can bring the negative 1 up, right? For example, if you had a over negative 1, you can write that as negative a over 1, can I not? Or I can bring it up and write it as negative a. These are all the same. So I'm going to write this as negative a, because it would be a divided by negative 1 plus 3. If you didn't do that, you'll still get the same answer. I just don't want to do an extra step. I'll kind of have an extra step anyways. Okay, so move the 3 over, negative 1 equals negative a, so a equals 1. If you did it the long way, you should get the same answer. So you're going to get y equals 1 over x minus 2 plus 3. Expand that out. Y equals 1 over x minus 2 plus 3 times x minus 2 over x minus 2. So y equals 1 plus 3x minus 6 over x minus 2. So y equals 3x minus 5 over x minus 2. And you can justify whether you did your math right, because remember, this up here gets your x-intercept, correct? So if I solve this out, it's 5/3. What's 5/3? 1 point something. Does my x-intercept look like 1 point something? Yeah, that's a good shot. What about this one? I have negative 4x over 5 minus 5. If I solve for that, it's x equals 5/4. That's 1 point something. Negative, sorry, 1 point something. And it's negative 1 point something. So you should be able to justify if you did your fraction stuff right if the top actually gets your x-intercept. Now, if it was just your x-intercept, you could put an x-intercept up here, but you'd still have to put an a and solve for a because there might be a vertical stretch on it, right? So you'd still have to check it. So that's what we're going to do for this. Because y equals a, x minus h plus k is a great form, but it doesn't take into account points of discontinuity because they've already been canceled off, right? So you wouldn't know they were there. So if you're given a point of discontinuity, the best way to do it is to get your equation. So if you have points of discontinuity, you're going to get your equation in this form. Y equals the x-intercept, technically, over the vertical asymptote, like the stuff that gets you that. And then the point of discontinuity, point of discontinuity. This will make sense in a second. But remember, you still have to have that a value in front because you need to test for a vertical stretch. So if you don't have a point of discontinuity, it's just y equals a over x minus h plus k. Do it. Don't worry about anything else. If you have a point of discontinuity, you have to go this format. X-intercept, vertical asymptote, p of d's. So these are actually going to be the exact same, right? Because they canceled off. That's how you know it's a point of discontinuity. And then you have to solve for your a value. So y equals, what's my x-intercept? My x-intercept's at negative 1. X equals negative 1. So what would it be up here? It wouldn't be negative 1. It would be x plus 1. Because when I solve x plus 1 out, I get x equals negative 1, right? What's my vertical asymptote at? X equals 1. So what would it have to have been in the denominator to get x equals 1? Because your vertical asymptote comes from your NPVs, right? So x minus 1 equals 0, x equals 1. You're just solving them backwards. So like your x-intercept was x equals negative 1. If I solve that backwards, I'd get x plus 1 equals 0. So that's why I'm putting x plus 1 in the top. Your vertical asymptote is at x equals negative 1. So this is your x-intercept. This is your vertical asymptote. It's at x equals negative 1. So if I solve it back, I'm going to get x equals, sorry, positive 1, right? Yeah. If I solve it back, I'm going to get x minus 1 equals 0. So this is what I'm putting in, the solved back version. Does that make sense? Then what's my point of discontinuity at? Is my y value actually, does my y value show up here at all? No, I find my y value by getting the x from the two that cancel and plug it back in, correct? So the only part of my point of discontinuity that matters right now is the x. My point of discontinuity, the x is at 3. So if I work that backwards, what would it be? X minus 3. If it's a point of discontinuity, it's on the top and on the bottom. What can't I forget to solve for? A. Remember, whenever you're solving every single time in any of the units, we always have to solve for that stretch factor and see if there is one there. So I'm going to have an A here, and then I pick a point. I'm going to use, is it negative 1 and 0? I'm going to use negative 1 and 0 as my xy. So I'm going to get negative 1 and, oh, it's not negative 1, 0. It's 0 and negative 1. So I'm going to get negative 1 equals A, 0 plus 1, 0 minus 3 over 0 minus 1, 0 minus 3. Negative 1 equals A times 1 times negative 3. These are multiplied, not added. So negative 3. Negative 1 times negative 3, positive 3. I'm going to bring the 3 up. Negative 3 equals A times negative 3. Divide by negative 3. A equals 1. Most of the time, these won't have a stretch factor, but you still have to check for it just in case they do. Okay? We always hope on the diploma we're like, no stretch factor, no stretch factor, no stretch factor, just in case you forget about it. So the end result is going to be y equals x plus 1, x minus 3, x minus 1, x minus 3. And how could they have it written in what form? They could FOIL the top and FOIL the bottom and have like x squared, blah, blah, right? So that's one example. This one over here, what's the catch on this one? It only has a point of discontinuity, correct? But what did I tell you to do? You're going to go y equals a, the x-intercept times the point of discontinuity over the vertical asymptote times the point of discontinuity. The only difference is this one doesn't have a vertical asymptote, correct? So I don't have that. What's my x-intercept? My x-intercept is x equals 6. If I work that backwards, that's x minus 6. What's my point of discontinuity at? What x value? Negative 1. When I work that back, it's x plus 1. And then I just solve for A. The only difference is this one. And why is this correct? Because then when this cancels, I'm left with a line. And what am I drawing here? A line. So I'm going to use, what is that, -6 and 0? 0 and -6, sorry. So -6 equals A times 0 minus 6 times 0 plus 1 over 0 plus 1. -6 equals A times -6 over 1. Divide by -6, A equals 1. So I get Y equals X minus 6 times X plus 1 over X plus 1. Okay? Let's steal this from you. So your homework is from 2 separate lessons. Tomorrow is review. I'm not moving on. So page 442.